All right, great. Thanks a lot. And thanks to folks that have dialed in for this replay of and a refresh in some sense, because this whole area of mobile application development and the IBM support for mobile development, particularly DevOps, has been rapidly changing, and there's some new developments since I delivered this with co-presenter Sanjeev Sharma in June in Orlando. So this is not only a replay but a refresh and an update on some of these topics. First thing we always want to mention as far as mobile and IBM is concerned, whether it's DevOps or mobile device management or whatever the mobile topic is, IBM early this year formed a distinct unit, a brand, a new brand called IBM MobileFirst. And this brand, MobileFirst, incorporates all of the mobile capabilities across the IBM corporation. So the DevOps solutions that we're going to talk about today, the mobile device management, mobile security, mobile analytics, as well as global services, consulting services for mobile development, mobile strategy, mobile application hosting, and even our partner relationships. For instance, our partnership with AT&T, our partnership between IBM and Apple, and many other mobile-specific partnerships are all part of this IBM MobileFirst portfolio of capabilities, which we believe, and the analysts agree with us, is the broadest mobile portfolio in the industry today. And so what I'll be talking about is one piece of a very broad and comprehensive mobile portfolio from IBM. Now, on the agenda, much the same as it was in June in Orlando, I'll take just a moment quickly to recap what the definition is for DevOps in general, what do we mean by that word, and then I'll get right into the mobile-specific topics, such as what are some of the specific things that make DevOps for mobile a bit more challenging than maybe for other kinds of software. And I'll run through a set of best practices for implementing DevOps for mobile development projects. And finally, I'll wrap up with some information about the solutions from IBM that enable those best practices for your mobile development teams. So DevOps, in general, is this notion of accelerating the mobile development life cycle, the complete cycle all the way from inception and design, coding, testing, delivery, and feedback for the delivered software. And it's certainly not a concept unique to mobile, but it's a concept that is particularly relevant to mobile application development because of the expectations that exist today that mobile application development and delivery will occur very rapidly. So when your delivery schedule for a software project is mapped out in some number of months, and you may have 12 to 18 months to deliver a release of that software, DevOps is a very good best practice, and it will help improve the quality and the speed of delivery for what you produce. But when your delivery schedule for some software, as is the case for mobile, is measured in days and weeks, and the expectation is that you'll update that mobile application every couple of weeks, even after it's released, then DevOps and Agile development methodologies become an absolute imperative. There's no way that you can succeed with a mobile development project unless your development team is using Agile methods and by extension employing DevOps capabilities to ensure that everything that you do is as efficient as possible and that you've removed as much waste from the process and inefficiency as you possibly can. So DevOps is all about speed to market and closing the feedback loop for the next iteration, the next sprint of your software delivery in general. Now, these DevOps principles certainly involve some tools, and we'll talk about some of those tools towards the end of the presentation today. But really, the larger adjustment that needs to be made is as far as people are concerned in your team and the processes by which they use to develop and deliver the software. The tools are to some degree the easier part or the more concrete part of the adjustment. There's a whole set of principles and best practices that your development team of the people on your development team need to adopt and really buy into, and the processes that they use are going to change in order to adopt those principles and best practices. And some examples of DevOps principles, again, somewhat general, not specific to mobile, are that you want to develop and test your software using as close to production environments as possible. And of course the idea here is that once you put that software into production, the difference between the environment in which you developed and tested it and the environment in which it will eventually execute is minimized. So that's sort of common sense. Another principle for DevOps is very rapid iterative deliveries using some kind of repeatable and consistent process. So this kind of points to the importance of automation and particularly the importance of defining as efficient a process as possible for the pipeline that's going to deliver your software. Even after you deliver the software, another DevOps principle is to continuously monitor what you've delivered and validate the operational quality of what you've delivered from out in production. Use that to close the feedback loop for the complete circle or the complete development cycle, and to particularly amplify and pay attention to those feedback loops as a first-class part of your development processes. Now, if all of this sounds a lot like Agile, it really is. DevOps and Agile really go together hand in hand, and we view DevOps in some sense as the operational personification of DevOps, of Agile principles put into practice. Now, there's some mobile-specific challenges when it comes to DevOps. The first mobile challenge is, while a lot of times we put a lot of focus on the code that runs on the mobile device, we talk about mobile apps, really that code on the mobile device is just one part of a larger ecosystem that makes up the full implementation of the so-called mobile app. So frequently, pretty much all the time, the mobile code that runs on the device is the point at which the user interacts with the application, but that code on the device is dependent on services and data that it retrieves over the network from what can be quite a complex multi-tiered architecture, the overall mobile ecosystem. So when you're automating and orchestrating the development and testing and delivery of the mobile application, you have to deal with more than just the code that runs on the mobile device. So that's an important realization to keep in mind when planning out a mobile DevOps solution. Another significant challenge when we're dealing with mobile apps and planning out the agile development process and DevOps solution for the project is that the code that runs on the mobile device doesn't just run on one kind of mobile device. There's a huge fragmentation in the mobile device marketplace. Obviously, we know Android has thousands of different permutations of devices and form factors and release levels that are out in the market. And even iOS, which used to have a much more narrow set of release platforms, is starting to get fairly broad and complex with the different form factors and operating system releases. iOS 7 is definitely very, very different than previous versions of that operating system. And while a lot of people have already upgraded, there's still going to be some reasonable number of legacy Apple mobile devices out there on the marketplace for some time. So developing your software in a way that supports all of those different mobile operating systems and manufacturers, device form factors, and so forth is a challenge. And then typically the application that runs on the mobile device can be a mix of different kind of technology. You may be using JavaScript for part of the application. If you're writing any native code as part of the mobile app, you'll have potentially Objective-C code or Java code in the case of Android. So the technology mix is a bit broader and varied, and the input mechanisms for the mobile applications are quite a bit more varied than traditional software as well. The final challenge for DevOps for mobile that I'll talk about is the App Store, and the fact that for more traditional data center delivered or web delivered applications or software, you as the enterprise have full control of the entire environment by which the application is delivered. In other words, you put the application on some servers and you can put your hand on those servers in your data center. You control those and you control when the application is updated or changed on those production servers. With these mobile applications, there's a disintermediary force there in between you and your ultimate end users, and that is the App Store. So you have to go through the App Store to deliver the mobile app to the devices that the end user is interacting with. And when you want to update that code on the mobile device, it's not up to you, it's up to the end user in conjunction with the notification that they get from the App Store. They decide when they upgrade or if they upgrade. And so that's a challenge in terms of making that whole process of delivery efficient when you don't own every piece of the chain. So we'll talk about some potential solutions for all of those challenges. But first I want to talk about what the development life cycle looks like for a mobile application project. And this is a somewhat idealized picture of the development life cycle for mobile apps. We developed this at IBM through several years of working with clients who are doing mobile development. And while not every project will make use of every one of these activities in the development life cycle, one of the important things to note about our representation here is that it is represented as a continuous process. There's no end, and to some degree there's not even a beginning. It's just a constant process of working on the code, delivering some set of backlog items, integrating with your existing back-end IT systems and infrastructure, testing to the degree that you're able to before scanning it and putting it into production, and then gaining insight from the application actually out in the field, in the hands of the users, in order to prioritize items to work on for the next sprint. And so it's just a constant cycle that your goal, and our goal is to help you with this, the goal for your development team is to go around that development life cycle as rapidly and efficiently as possible. So to that end, we've developed a set of best practices for DevOps for mobile. And so we'll talk through some of those now. The first best practice is to use continuous integration. Now, obviously continuous integration isn't something new or unique to mobile, but again, it's part of that realization that because of the expectations for delivery time frames for mobile apps, agile methodologies, including this continuous integration concept, are absolutely imperative. And of course, the idea here is that you have various people working on the code for the mobile application. You want to, as soon as they deliver a code change, you want to run an integration build that combines their code delivery with that of the other team members and produces, very, very quickly a build of that new version of the mobile application, which you then take through the rest of the whole process in order to validate and get feedback to the developers as quickly as possible, whether the code change they made was effective or if there was a problem introduced by that code change. And so that's one of the best practices. Another best practice when you're doing those continuous integration builds is to be very careful, particularly for Android. This is applicable. Be very careful about organizing the different SDKs of the native operating system for the mobile devices that you're supporting, and carefully separating them so that they don't get munged together or mixed up when you run a build that supports a specific level of the operating system. So in a sense, we're talking about careful control over the common integration build structure and the build servers that you're using. A third best practice is to always be sure that you treat the build scripts and subsequent deployment scripts, any of the automation artifacts that you use in the DevOps development process, treat those scripts as source code themselves. Put them under change control in a SCM repository and track them with work items and really treat the build and deploy automation scripts as source code, just like any other part of the application. Yet another best practice is to be sure to test the build output with each continuous integration build, to test it on real devices, not just emulators. Emulator can be pretty handy for a bit of a sniff test, but really the emulators are not a good proxy for what an application is really going to behave like on a real device. So you want to do at least some amount of testing with each build on the real devices that some small subset perhaps of the devices that you are planning to support with this mobile application before declaring the build really good to proceed to the next stage of the pipeline. Yet another test-related best practice is to simulate the back-end services that your mobile application will be interacting with. It can be quite costly to keep a very close to production-like environment up and running just so that you can run the regression tests for the latest continuous integration build output for the code that's going to run on the mobile device. So best practice here that we've seen great return on investment for customers is to actually simulate all of that back-end interaction with the mobile device, and you get the added benefit of not only more efficient testing, always available and consistent, but you can inject corner cases into the responses that come back from the simulation that would be very difficult for a real system to produce. You can inject pauses or error responses that it could be very difficult to force a real production system to deliver. And so you get a better quality result as far as the testing goes, in addition to much more efficient and consistent testing results. So another best practice is to monitor the application as well as the services that the application is interacting with once you get it out into production and into the end user's hands. So there's two parts to this really. You want to be monitoring your back-end services to ensure that they're scaling properly and handling the load, because the number of end users and the amount of activity that your back-end services may be loaded up with can be surprising from a mobile application. You could put out a mobile application and very quickly find that there's hundreds of thousands, if not millions, of end users that have downloaded and installed that app and are starting to interact with the rest of the whole mobile application ecosystem and putting it under load. So you want to watch that carefully, as well as infusing the mobile application itself with additional intelligence to provide your development organization insight into how that mobile app is behaving out in the field in real end users' hands. This is part of that closing the feedback loop for mobile DevOps and a best practice. Another important best practice for mobile DevOps is to carefully manage the certificates, provisioning profiles in the case of iOS applications, and other various keys that are artifacts that you will use to sign and otherwise manage your mobile application in production. But frequently, you see these situations where the developer you'll have a developer who has these items, these artifacts, just sort of sitting on their workstation instead of putting them under a centralized control and really applying them as part of the central shared continuous integration build. So you really want to put those sensitive development artifacts under some kind of governance as part of your overall development processes. Use of an app store-like environment during the pre-production testing phase is important in order to ensure that your application it will work when you actually put it out in the real app store. I've seen these cases where you're working in the IDE, building the code for the mobile app. You just use the capabilities that are built into the development environment to push the app directly onto the emulator that's part of the SDK that the developer is working on. And everything's working just fine. The app comes up and it runs just fine. Then later, you take the build output from that app and put it in an app store, and someone goes to download it, and lo and behold, it actually won't run at all. And I literally saw this just yesterday on a project I was helping out with, where that happened. They didn't test it out beforehand in a development app store environment. So that's an important step in the process that you don't want to shortcut. Just like you want to use some real device testing in addition to any emulator-based testing, you want to at least try using the mobile app through an app store process in addition to any other way in which you deploy the mobile code. So that's another best practice. And then the feedback part of the whole process is a really key element. In addition to monitoring the application itself, you want to monitor the sentiment that end users are expressing about your mobile application once it's out in the field. Because you can have a mobile app that's functionally perfect. It does exactly what you had planned for it to do functionally, and yet the users, it could be a failure because the users will just hate it, and they'll put negative reviews in the App Store and remove the application from their device because of some non-functional usability kinds of issues. So you know that's all part of the perceived quality of the deliverable, and you need to put some effort into monitoring that aspect of the user sentiment about the mobile application, and bring that back into the development process as well. So we've talked about what DevOps is in general, and specifically some of the challenges that are unique to mobile projects as far as DevOps is concerned, and kind of quickly run through some best practices related to applying DevOps to mobile projects. Now we'll talk a little bit about specific solutions that IBM has to offer that help you put into practice those best practices that I've just talked about. Once again, we can talk about this in the context of the overall development life cycle and the tools and products and solutions that we have that address the various tasks that are part of this continuous development life cycle. Now, the first thing I want to talk about is when you're designing and writing the code and actually implementing the mobile application. IBM and IBM MobileFirst have a mobile application development platform that's based on an acquisition that we acquired almost 2 years ago now, and have continually invested in enhancements for. That's known as WorkLight. And the WorkLight Studio is the development IDE for mobile apps. It's a very rich combination of tools, everything from the more traditional code construction tools to a rich WYSIWYG mobile UI construction tool, a preview tool that lets you get a good idea of what the UI will look like on different device form factors, and even some recently some integrated mobile automated test capability in the studio. So a really advanced development tool for your mobile application code that is tightly aligned with the runtimes that are part of WorkLight. And there's runtimes for each of the major mobile operating systems that provide access to the various features that are available on the mobile device using a single programming model to access those device-level services and features. And there's also a server runtime that's very important because many times some of the key aspects of your mobile application are driven from a server, like push notifications, for instance, being one. And the WorkLight platform has a single programming model that covers all of the different mobile operating system notification services. You just write the push notification once, and the framework figures out the right mobile operating system messaging arrangement to deliver the notification out to all the different end users. There's an operational console in WorkLight that provides you with the management capabilities of the individual applications. You can, for instance, force an upgrade after the application has been put into production, as well as see the various reports and analytics that are collected as well. And there is the Application Center, which is one of those private App Store environments that I mentioned is in the best practices. Allows your development organization to use a App Store in their development process and not get surprises when they put the app out in the App Store afterwards. So IBM WorkLight is a big element of the coding and development of a mobile app. But your development team, especially using DevOps principles and Agile methodology, is going to want a solution for defining assigning the backlog stories to the various Scrum iterations, tracking the stories and associated work items, filing defects, tracking defects, running a continuous integration central shared mobile build, and all of those Agile team collaborative development capabilities. Now, IBM has a solution that's award-winning. We again made the Magic Quadrant this year for our development capabilities, our collaborative lifecycle development solution, and that's very tightly integrated with the mobile IDE. And so your development team can be as effective as possible individually with the WorkLight Studio IDE, as well as effective as a team through collaborative development and our lifecycle tools that are completely integrated with the MobileFirst development platform. Part of that fully integrated solution includes mobile-specific testing. Earlier this year, we released IBM Mobile function test automation capability. We released this capability in 2 different products. It is part of Worklight Studio, but it's also a component part of our broader test workbench solution. So this mobile function test automation capability allows you to put the application into record mode, interact with the application as you normally would by pinching and swiping and tapping and entering text and whatever. And as you're interacting with the mobile application normally, when it's in record mode, we capture all of that user interaction and store it as a automation script that you can then replay over and over against the mobile app in subsequent builds, and you can run that automation test against the application even on devices other than the one used to record the test on. So you can, with the upcoming release 8.5.1 of Rational Test Workbench, you'll be able to record using an Android device, and if you have a hybrid application that also runs on iOS, you can replay the test script against the application running on an iOS device. So the ability to save your test organization extra time creating multiple automation scripts. That's unnecessary now with this solution. So a great capability, supports iOS obviously and Android, both native and hybrid applications, and it's integrated with the Worklight Studio as well as the test workbench, and can be managed overall by our Rational Quality Manager test management solution that can automate and manage the entire process. Now, another component part of the Rational Test Workbench gets back to one of those best practices that I mentioned, the notion of isolating various parts of the overall end-to-end application, so you can focus the testing on just one specific aspect or tier of the mobile app. And in this case, we have a capability in Rational Test Workbench known as service virtualization that allows you to isolate and simulate different component parts of software in general, and specifically for a mobile app, you can simulate the middle tier and back-end systems that the code running on the mobile device will be calling when you're running the functional automation tests on the app on a real device. And this simulation of the middle and back-end services and data sources is very cost-effective. The return on investment for this solution is extremely high. You get much more consistent results in your tests, and you get the added benefit that you can inject corner cases into the simulation to respond back to the mobile app code, and these corner cases might be very difficult to force a real running system to produce. So with the simulator, you can control quite a bit more the actual responses from the middle tiers and so forth. Now, we talked about once you get the application out into testers' hands, and then even beyond that into production, the need to very rapidly capture feedback information, whether it's defects that the testers are identifying as they interact with the mobile app, or just response from real end users that would rather take just a second to tell you something, but aren't going to be willing to take the time to go back to the App Store and write a full-blown review of your mobile application there. So capturing feedback is important. And as I mentioned earlier, in addition to understanding how well a mobile application works, it's key to also understand what end users really are thinking about it, how much they like it, and to channel this kind of feedback into the use cases and user stories that are on your backlog for the next sprint of your development cycle. Now we have a set of hosted services that is very recently become available, and the intent of these services is to help address the various needs of various users, various people that are playing different roles in your development team for the mobile application. For instance, you might have the stakeholder down in the lower left, a line of business person or our digital marketer who's at a high level looking at this mobile application and wanting to understand what the users think about it and how they feel about this mobile application so that they can sort of judge the overall end result. The developers are constantly frustrated because the mobile application is out in some user's hands in production, and maybe it's crashing or there's some problem the user is experiencing, and they can't get even typical must-gather kinds of data about the crash or the particular environment, the device on which the mobile application is currently running, where the user is stating that there's a problem or a defect. So the developers are looking for a better way of getting the full information that they need in order to really figure out how to fix the problem. Testers are looking for the ability to directly create defects without having to put the mobile phone that they're testing on down and go over to a separate laptop and use a separate program to enter in the defect information. And it can be really difficult as a tester to actually even capture all of the information that is needed by the developers in order to fully describe the defect. So they're looking for the ability to actually do a screen capture when they find a defect, annotate it, and capture all of the information about the device and the application state at the point at which they have located this defect. And like I said, even real end users in today's mobile world have an interest in providing feedback to if they at all like the application, they're more than willing to provide information back to the development organization that you want to capture in order to have a full understanding of the round trip. So our mobile quality assurance services are now live. You can see the URL there, qualityformobile.com, and these are services that are hosted by IBM. You don't have to install anything on your servers. There is an SDK that you download and use in conjunction with developing the code for your mobile application, and it provides 5 different capabilities related to the feedback aspects of the development lifecycle. So we can support over-the-air build distribution to testers. Testers can open defects directly from in the mobile application while they're testing it and capture all of the information about the state of the app and the device it's running on automatically and have that be part of the defect that goes back to the development team, as well as crash reports. Every time a crash occurs, I would capture all the data about the crash and send that back to the service so we can capture it. End users also are able to provide feedback about what they think directly from inside the application very efficiently. And we're also set to deliver as part of these services something we call sentiment analysis, where we analyze if you have thousands of reviews in the App Store, we'll analyze the text in those reviews and provide you with quantitative scoring on about 10 different dimensions by which your users can express their opinion or sentiment about your app, everything from its stability, its performance, its usability, and so forth. So important information to capture and channel back into the next iteration of your delivery of the mobile app. Finally, and this is the developer works page for the new mobile quality assurance services that are out there. We encourage everyone to go out and try it, and it's certainly free for some amount of time here going forward. Now, one final solution to mention, very key to DevOps in general and mobile in specific, is our acquisition of Urban Code. IBM acquired Urban Code earlier this year, and Urban Code has a set of tools that specifically are designed to automate and orchestrate the development process to drive all of the inefficiency out of the development process for software in general, and specifically for mobile development lifecycle processes. Urban Code as a solution has an architecture that includes a automation engine and a variety of different plugins. And the plugins for Urban Code are where the intelligence exists for how the DevOps solution can interact with a particular tool and most effectively automate and coordinate the activity related to that tool. So there's hundreds of plugins already for Urban Code, all kinds of IBM and non-IBM development tools that people commonly use. Just recently, a few weeks ago, we updated the plugins with a set that are specific to the IBM MobileFirst platform, or the WorkLight platform, as I mentioned earlier. So now you can, in addition to automating and coordinating the release of other parts of the end-to-end mobile application, the other tiers, such as the middle tier or even mainframe delivery, you can automate the deployment of the build output for WorkLight targeted mobile applications. And what this really allows you to do is coordinate across multiple tiers. You may have infrequent updates of your mainframe transactional services, illustrated at the bottom of this slide, more frequent updates in the middle tier, where you're able, through web services, to update more frequently the APIs that the mobile device would use. And, of course, your mobile tier is probably going to be going through deployments on a weekly basis or something along that time frame, much more rapid than the other tiers. But you want to, one of the key challenges is some update to the mobile application may be dependent on an API change in the middle or back end tiers, and you don't want to put out the mobile update before you've ensured that the middle tier or back end change has been put into production. So this is another challenge that Urban Code solutions can address for your project. So in closing, IBM MobileFirst is the key brand for mobile across all of IBM's software and services and even partnerships. And part of that portfolio, which is quite comprehensive, is a set of DevOps-related solutions to accelerate and make more efficient your mobile application development processes, but you do need to ensure that your DevOps journey includes the people and the processes in addition to the tools that I was just talking about. With that, I'd like to take the last few minutes of this webcast to open the floor for any questions. Cesar?
Thanks, Lee. We do have a question here. Do IBM DevOps solutions work on Mac OS?
Oh yeah, that's a good question. I didn't really mention that because a lot of mobile development occurs on Mac workstations because Apple, for iOS development, you are forced to use Mac. The Xcode Apple development environment doesn't work on any other kind of workstation. And in fact, you can do, for instance, Android development and iOS development both on a Mac workstation. So it's really important for development solutions for mobile, particularly, to be supported on Mac OS. And all of the solutions that I mentioned are supported on Mac OS. So for instance, the WorkLight Studio runs on Mac OS and integrates with Xcode, in fact, in addition to integrating with the Android native SDK as well. And the testing works on Mac OS, and our SDKs are supported. We have iOS versions of those that are supported on Mac OS. So, everything in the mobile space that we do gets Mac OS first-class support.
Excellent. There's another question here. Is there an evaluation version of WorkLight?
Yes, there is. WorkLight Studio, the developer edition, you can access that on IBM DeveloperWorks. It's real easy. Just Google WorkLight Studio. I think it's probably the first search hit that comes up at the top of the list. The DeveloperWorks site, and you can get the free download. It's real easy to download and install and get set up and going, and create your first mobile application in literally a matter of maybe an hour or maybe 2 hours. So it's really neat. We encourage everybody to go out and download that and give it a try. It's free.
Great. And what kind of mobile apps work best for DevOps? Native or hybrid or maybe web apps?
Oh yeah, okay, that's a good question too. I didn't get into that. There's this whole debate in the industry about what's the best way to implement your mobile applications. There's one school of thought that says that it's only writing using the native mobile operating system APIs and language is the only way to do mobile. You got to write an Objective-C using iOS native APIs or Java and Android APIs. There's another school of thought that says, mobile web applications, regular web applications that have been redesigned to work well on a browser or on a mobile device, that's the way to go. And then there's this hybrid approach to mobile application development that's kind of a mix. It says you can use a web application technology like HTML5 and JavaScript, but you bake it into an installable app that goes out in the App Store and makes use of mapping runtime to allow the mobile application to take advantage of the services and capabilities of the mobile device that it's running on. and it supports across all the different operating systems. So there's no, one implementation style for mobile apps that's perfect for all mobile apps. I think the debate is a little irrelevant in a sense, because you want to make that implementation choice on a application by application basis based on what that application is doing and how it's dealing with its content and other kinds of requirements for that specific application. So in some cases, it may be best to use native code. In other kinds of situations, you may want to use a hybrid approach or a mobile web approach. And in each of those decisions, based on that individual app, that different implementation style is the right one. So the implication of that, much like the Mac OS support question earlier, the implications of that on our DevOps tools is that our DevOps solutions have to support all the different implementation styles, and they do. So the answer to the question is actually there isn't one style of mobile application coding or implementation that's best for mobile DevOps. Mobile DevOps supports all of the different styles of implementation, and it's important that we do, because depending on the individual application, native may be the preferred, or hybrid, or some other form. So we support all. It doesn't lock you into any one implementation style. You can choose the best one for your specific application under development.
Great, thanks. I think we have one last question here. Is there a best mobile testing strategy for a rapid delivery lifecycle?
Well, we've kind of developed a point of view for a testing strategy for mobile apps that we, based on working with a number of development projects, it seems to be the best balance of good results compared to the speed with which you can get the testing done. And so that strategy is to create an automated regression test suite of test cases that you can execute pretty rapidly with each build, and to run those on a small set of representative real devices, again, for each continuous integration build. So you can quickly catch the big failures that may creep into an individual build. Then you want to combine that automation with some manual testing, because mobile applications are all about the user interaction, and we call them systems of engagement for a particular reason. They engage the end user. So manual testing is still an important element, but you can use something like over-the-air distribution of the build, notify your testers that a new build is ready, and they can download it quickly to their device and start testing with it. And then ultimately, and time box that, a couple of hours or whatever. And then the important thing in the strategy to realize is it's impossible to exhaustively test even one build of a mobile application on every combination of every different kind of device and form factor and operating system release and carrier radio chip and every other thing. The permutations are just way too vast. You're never going to test in the lab before you put it into production on every permutation. It would just take months to do that. So the key is to do as much automated testing as you can against a representative set of devices. Couple that with some quick manual tests with your, some set of testers in an efficient process, and then be sure that you're also embedding in the mobile application the ability for it to quickly report problems in the field back to you as a development team, so that if there's something that you couldn't catch before it goes into production, you can at least catch it out in production quickly and get it fixed quickly. And that seems to be the best balance of testing strategy. It includes pre-production testing and post-production monitoring, in a sense.
Great. I think those are all the questions. Thank you guys for attending, and have a great rest of your day.